Okay, got it going. All right, welcome to another session with the virtual Kansas City SQL Server user group. Tonight we have a holiday bonus with Deepthi Goguri and her session, New Performance Features in SQL Server 2022. For the audience, this session is recorded and will be uploaded to our YouTube channel. Once the recording is ready, I will place a link inside the meetup event and various other places. You can always check out our YouTube channel to see the listings. QA will be live throughout the session, so feel free to ask, and I'll just look for a pause to ask the questions. Performance is always a hot topic with any SQL database. So on that note, welcome Deepthi, and thank you so much for speaking with us this evening. I'm going to let you take over at this point.
Thank you, Christina. That's a great introduction. So thank you so much again for giving me this opportunity to present for your user group. I'm so excited and looking forward for this presentation. So basically today I'm going to talk about the new performance features in SQL Server 2022. This is basically I'm still building up this presentation, so I did as much as I can uh, with the demos and stuff. I am still going to add more demos to it. So I just want to put that just before even starting the presentation. So yeah.
Sure.
So a little bit about me. I'm a database administrator. My name is Deepthi Goguri, and I'm a Microsoft Data Platform MVP. And I did my master's in computer technology at Eastern Illinois University in Chicago a couple of years ago. And also I do volunteering. I'm a co-organizer for a couple of user groups that are shown here. I'm a co-organizer for Data and AI South Florida user group, DEI user group, Diversity, Equity, and Inclusion, and also for the Data TGIF. Um, and I do volunteer for Women in Technology user group as well. And apart from my work, my day-to-day work and my community work, I love arts and crafts, and I love plants. I didn't add it here, but I recently started reading philosophy, so I'm totally into philosophy at this point of time, apart from my other work. So yeah, if you have any questions regarding this session later, if you couldn't ask here or if you are shy, you can definitely contact me on Twitter at dbnuggets is my user ID, and I usually blog about SQL Server on my website dbnuggets.com. So if you are interested, please go ahead and look into it. And I'm very active on LinkedIn as well. I usually post all my blog posts and my upcoming presentations and stuff. So if you would like to contact me there, LinkedIn, I would be happy to connect with you. So as per the agenda, we are going to mainly talk about the latest features added in SQL Server 2022. So if you are familiar with Query Store, it is released in 2016, way back in 2016, but they have been adding the latest features, like the new features and advancements to it. But especially in SQL Server 2022, they have added Query Store hints. So in this session, we are going to talk about how the query store hints actually work, and we have a demo on it. And based upon that query store, there are several other IQP features, intelligent query performance features in SQL Server 2022 that are dependent upon the query store. So basically, query store feature will actually, once you enable it on the database, it's a database level feature. Once you enable it on the database, it will capture all of your queries, execution plans, and the resource consumption information, and then it will store the data in the primary data file of the database where you enable the query store. So um, they have taken the advantage of the query store in SQL Server 2022 and build the intelligent query performance features, or like add more advancements to the existing IQP features to take the advantage of the query store data, because we have history of the query execution information in it. So they have taken that advantage of the captured information, the statistics and everything, and then they have added the advancements to these IQP features that are listed here. Like for example, the memory, the parameter sensitive plan optimization, the first one, it actually doesn't require the query store. This is the only IQP feature which is in SQL Server 2022 that doesn't require query store. But as in SQL Server 2022, query store is by default enabled on the new databases. So if you have a new database that's built on SQL Server 2022, and then if you have this IQP feature like parameter sense to plan optimization, if you're taking the advantage of it, you can grab some information from the query store regarding that as well. So it's an advantage, but it actually doesn't require query store to take the advantage of that particular IQP feature. But the rest of them, the memory grant feedback, degree of parallelism feedback, and cardinality estimation feedback, all of these three require the query store because it will grab all the collected data from the history, like it will actually monitor the queries from because it those that is actually like what can I say, like the the work, the query work, right? How many times your query gets executed, and based upon those um, feedback that has been stored in the query store, these features will take the advantage. So we are going to talk about those as well. So before beginning, I have put a slide of like how query store actually works. There is a reason why I put this. This is not a query store session, but like I said, most of the IQP features that we are going to talk today are depending upon the query store. So it is better to understand how the query store works behind the scenes before talking about the IQP features. So any query, let's say we have a query on a database and we have enabled the query store on the database. And let's say like we started collecting the um, execution plans, and then we started collecting all of that information. Once you enable it, it will automatically capture that information and store in the primary data file of the database. So let's say you collected some information and then you thought like the main advantage, the one of the biggest advantage of having the query store is you can force a plan which you think is optimal. Usually, the SQL Server optimizer and like SQL um, engine will decide that for us. Like it will almost always choose the optimal plans. But in some scenarios where you might have the parameter sniffing problem, or you might be having like your plan might be out of the plan cache for some reason, like if you restarted the SQL Server, the plans will get out of the cache, or like if you rebuild the indexes, and then that will also recreate the statistics automatically upon those indexes. So in those situations, SQL engine will force the query to generate a new plan as well. So in those kind of situations, then there might be the new plan that gets generated to your query, and that might not be the optimal plan based upon the parameter value that you pass. If the parameter value that you pass is not a good parameter, then a then there will be a plan that got saved in the plan cache, and the next time you run with any other parameter, it will go ahead and use the same plan, and that will cause a performance problems, right? So all of this will be stored inside the query store, and you know that the currently generated plan is not working fine, but the previously running query plan was working fine. By using the query store, you can actually go ahead and look at that old plan that was working fine and then force that plan, so that from once you force the plan, the next time you run the query, no matter what parameter you use, let's say store procedure, it will go ahead and use that force plan, and you can solve the problem immediately, almost immediately, until you actually fix the query of the problem. If the query itself is a problem, then you have to definitely work like work with that query, fix the problem permanently by redesigning the entire code of your store procedure. But not all the time you have the ability to go ahead and change the query. Like if everything is on fire, like if you are a DBA and you're getting a call at 2 a.m. in the morning, if that pager rings 2 a.m. in the morning, you just can't figure it out. What's the problem in the query? How do I fix it? Can I talk to the developer? That's not the scenario over there, right? The first thing we think about is let me fix this problem. Let me fix this problem first, because nobody wants to wait for such long time to fix the actual query. So that is one of the advantage of using the query store. So you might be thinking you put a slide on the presentation and you're talking something else. But why I'm talking that is because like if, for example, we forced a plan, let's think the query that we are running already have a forced plan with the query store. And what will happen if that query is running on the SQL Server? So let's say that query where let's say we have a plan. We have a plan and we force that plan, right? And that query is running again. Let's see what will happen behind the scenes inside the SQL engine. So that any query, this will happen with any query, but let's say like this particular query has a force plan. So that query is running on the SQL Server. So the first thing that will happen is it will check like if it is running for the first time on the SQL Server. So if it is running for the first time, then it will go ahead and do the compilation and the optimization phases and build a plan. Now, if it is not running for the first time, it will go ahead and check if there is already a plan in the cache. If there is a plan in the cache, that's a different scenario. But if there is no plan in the cache, like I said, if there is a memory pressure on the SQL Server, the first thing that will happen is like it will clear out the least recently used plans from the plan cache. That is the first thing that will happen to allocate the memory wherever it needs. The first thing that will happen is like delete certain plans, like least recently used plans from the cache. So let's say there is no plan because like i- plan is like the cache is flushed. Um, Flush out the plan is not there. So let's say there is no plan. Then again, it will go ahead through the compilation and the optimization phase and then build a new plan. But if it is already in the cache, then all right, it will go ahead and use that a plan in the cache. But do you remember we thought like this particular query has already have a forced plan on the top of it, right? So it will go ahead and check for the recompilation. Now, what will happen during this phase? It will go ahead and check if this plan, whether the plan that it has taken from the cache or the plan that has been just compiled, right, is the same as a forced plan. Because inside the query store, we have forced plan. So it will go ahead and compare and check if it is similar to the forced plan. Sometimes it might not be similar because like we might have updated the stats or like data has been inserted a lot that might have changed the query plan. It can be many reasons why the plan might be different from the forced plan. If that is the case, then it will go ahead and apply that forced plan. It will force that forced plan. But if it is similar to the forced plan, it will go ahead and use the same plan. That will happen during the check for recompilation phase, and next it will go to the next step. But before going into the execution phase, the first thing that will happen is even before execution, the query text and the query plan will be saved inside the memory. So whenever you enable the query store on the database, there are certain memories that will be enabled. There are certain stores that will be enabled, especially for the query store. So those are like the plan store and the runtime stat store. These are in the memory. So the first thing that will happen before the query goes to the execution phase is like it will capture the query text and the query plan inside the plan store here. And this process will happen asynchronously. And once the query plan and the query text gets stored inside the plan store, then the query will go to the execution phase. So during the execution phase, once the query gets executed, again the runtime starts. To collect the runtime stats, the query needs to be executed, right? So that runtime stats will be saved inside the runtime stats store inside the memory, and this process will happen asynchronously as well. And once that data has been collected in the memory stores, then at particular time, like there is something known as a flush out interval, and that is by default for query store, it's 15 minutes. So every 15 minutes, all the collected data inside the memory will be flushed out to the query store schema, which is inside the primary data file of the database, where you enable the query store. So every 15 minutes, it will go ahead and asynchronously push that data into the query store schema and harden to the disk. But sometimes when you have memory pressure on the server, sometimes even before hitting that 15-minute interval, that data, the captured data inside the memory, can be flushed out to the query store schema as well. So that's how the query store actually works behind the scenes. And most of these IQP features will use this query store information by querying through the views. It will get the information out of that query store schema, and through the views we can clearly see that information of what it has collected, and it will these IQP features will save the feedback information inside the query store schema as well, and then use it. So you might be thinking like, why do why do these IQP features use the query store when we actually have the plan cache, right? Like we discussed, like plan cache is like flushed out every time we restart the SQL server. And if that is the case, what's the point of having these feedbacks saved inside anywhere, right? How do we have these feedbacks every time we restart the SQL server, just like the DMVs, everything get flushed out. In that particular scenarios, we couldn't use the we couldn't take the advantage of these IQP features. So that's the reason, like if you use the query store, all of that information that's already in the plan cache, which is the plans, right? Execution plans. Along with the execution plans, all the resource consumption information and everything will be saved inside the query store, and it will be retaining the data even upon the restart of the server. So only the data will be flushed out to disk from the memory is when you set up the configuration in the flush out intervals. That's when the data will be flushed out from the memory to the disk for the query store schema. But the data is always retained, and it will be retained until the cleanup policy. So the minimum cleanup policy, like the default cleanup policy, is 30 days for the query store. But for the plan cache, every time SQL Server restarts, that's the cleanup policy, let's say, right? But with the query store, we have how many days you want. You can put that in the configuration. And with the plan cache, we can only see the latest plans. Now, if there is a memory pressure, the least recently used plans will be out of the cache. They have to generate again when they run the next time. But with the query store, the collection is always there over time, and it is persisted. Plan cache evicted on the memory pressure, but query store, until it reaches us the flush out intervals, it will not push the data to the disk. And it is very difficult to know like why the plan has changed with the plan cache. But with the query store, you can see the history of the plans. Because you can see the history of the plans, you can compare, and you will know like why the plan might have changed. And it will be easy for you to troubleshoot the performance problems. So what are the query store advancements? We have seen the basics of how query store works and why is it different from the plan cache and how the IQP features uses it. But what are the advancements that we have in SQL Server 2022? In SQL Server 2022, if you are creating a new database in SQL Server 2022, then it is enabled, query store is enabled by default. But if you are upgrading your databases from the lower environments, like from the previous SQL Server versions to the latest SQL Server 2022, then that configuration will not be changed. If your old database from where you are migrating, if that environment do not have the query store enabled on your database, it will not be carried over. You need to manually go ahead and enable the query store if you want. And um, in SQL Server 2022, they have updated the internal memory limits for the ad hoc workloads. Before SQL Server 2022, if you have more of these ad hoc workloads, each ad hoc query can generate an entirely different query ID. So if you have more ad hoc queries, that might blow up your query store, because whenever you enable the query store, you need to configure the space for the query store inside your database. So if you have lot of ad hoc workloads, then that might fill up the query store quickly, because each execution, even its slightest change, like adding a space or like adding a comment, can create an entire different query ID. So it used to fill up the query store. Many people complained about it, like, hey, I have these workloads, but we I'm seeing like query store getting filled up, and the query store is going to the read-only mode, because once the query store is filled up, the query store will automatically by default turn off, and it will put it in read-only mode. So during the read-only mode, if you have any forced plans, then those forced plans will be taken into consideration. They will be used, but it cannot write anything to the query store. So they have these problems. Though we have like a couple of queries where we can clear out all the ad hoc workloads from the query store. It can clear out all the collected information, but then like you need to create an agent job, schedule it, run it all the time to clear out. But because this has been a problem in SQL Server 2022, they have actually did the internal memory limit for the ad hoc workloads, so that your query store doesn't have to go to the read-only mode. And then, um, and then you have the advantage of the query store hints. We can use the query store hints. I'm going to talk about that in our demo. But like, let me go ahead and talk about like intelligent query processing, one of the intelligent query processing, and then let's go to the demo and then come back again and talk about the other IQP features. So in the intelligent query performance, like query processing, before SQL Server 2017 and before SQL Server 2017, intelligent query processing is known as adaptive query processing. But then in 2019, they have added all of these additional IQP features, and they have renamed the adaptive query processing as the intelligent query processing. And if you see the bottom of the page, you can see the color coding, like the like sea green color is all the features which are introduced in SQL Server 2017. And then in SQL Server 2019, they have added all of those. And the SQL Server 2022, the IQP features are the blue color, the dark blue color. All of those features are released in SQL Server 2022. So we are going to talk about the parameter sensitive plan optimization first, and then go to the next ones. So highlights of all of these IQP features is that to enable these IQP features, you do not have to do anything. Like, there are no code changes needed. All you have to make sure is your database is in the latest compatibility mode, which is equal to SQL Server 2022. That's all you have to do. You have to make sure like the database is in the latest compatibility level, and then automatically all of these IQP features will be um, supportive to your query. All the feedbacks will be getting collected, and then the IQP features will be taking the action onto the queries. And there will be a lot of positive impact in performance once you put the database in the latest compatibility mode, because it will automatically take the advantage of these IQP features. And if one IQP feature is working on your query, doesn't mean like the others are in the sleep mode. They can work together. Multiple IQP features can work on your queries together. So like the query store advancement that we talked about, couple of them enabled by default. And the other advancement is that the query store data is also captured for the secondary replicas. So before SQL Server 2022, like we do not have this feature. If you are having the always on availability groups, only the primary read-write replica used to collect that query store information, and the read-only copy doesn't have that option. So there were many companies who actually requested for this, and so in SQL Server 2022, once you enable the query store on the primary read-write replica, there are certain configuration options where you execute on the primary read-write replica, where you'll tell the query store to also enable the query store on the read-only replicas as well. You just can't enable the read-only replicas on the read-only because databases are read-only, right? So you will execute the option to enable it on the primary read-write replica. Any changes that you want to do, even like you can also force the plan on the read-only replica, but by running the store procedures on the read-write replica. There are certain parameters where you can choose like whether you want to uh, push that change onto all of the read-only replicas or just one, or like you want to do that across the board, such kind of configuration options. Query store hints, like I said, and the parameter sensitive plan optimization. Like I said, these are all the features that got like advancements in SQL Server 2022. Only the parameter sensitive plan optimization doesn't require the query store. So let's talk about the parameter sensitive plan optimization. This is also known as PSP optimization. So basically, if you have any parameter sensitive parameter sniffing problem, and then you do not have like a proper distribution in your data, and like one parameter might give you like most of your parameters might give you like couple of records, like even out records, like approximately similar amount of data, but then there are like certain parameters where like there is like 100x of change, like 10x of difference in the number of records that you see. Let's say there is this stored procedure where most of the parameters give only like couple of hundreds of records, but then there are like some parameters in it which will just give me like millions of records for the same stored procedures with a different parameter. And until the usual SQL engine will go ahead and create the execution plan, and the moment that you execute a stored procedure with such kind of parameter which have like too many records, but then that's not a good parameter because most of your executions will just give like couple of hundreds of records, right? So if at all the time that you execute is the time when the SQL Server will build the plan, and that's not the optimal plan, and that will cause a problem because now that plan is using clustered index scan. It is scanning the entire table, and you do not want that. You are good with index seek and key lookup because most of the parameters do the index seek and key lookup. They are good with that, and like low resources are consumed to execute that plan. But because of that parameter sniffing problem, you really have a problem because like now like bad plan is saved, and like that plan is being used, and the only way that you can solve the problem is to put the recompile, and then to do the recompile you need to touch the code. Lot of problems. But with the parameter sensitive plan optimization, this is one of the IQP features where SQL engine will go ahead and save multiple plans in your plan cache so that you do not have to go ahead and recompile those plans. Because until now, there is only one plan that got saved for the query. But because of this IQP feature, PSP optimization, maximum up to 3 plans will be saved inside your plan cache, and based upon your parameter value, SQL engine will decide which plan to choose, and you do not have to worry about like parameter sensitive problem, like parameter sniffing problem anymore most of the times. So parameter sensitive plan optimization do this? Because we know that it is not using the query store, but what is a method behind this, right? So there is something known as dispatcher and the variant plans. Dispatcher, so let's say we are running a query, right? The parameter sensitive query with a parameter. So there is something known as a dispatcher plan in SQL Server 2022. They have introduced. Dispatcher plan is like it's like a tree where it will show the direction to the SQL engine where it have to go, what plan it have to use based upon how many results it is producing. This dispatcher plan will have like, for example, the query will be executed and this dispatcher plan will see like how many records does this query gets will it produce, like how do it get that information? By looking at the statistics information, you know, the statistics, right? The table statistics that you have, like anytime SQL engine have to decide like how much memory it have to allocate for the query execution, or like what kind of operator it have to use in the plan, or like what index it have to use. Statistics are the place, it's a go-to place for the SQL engine. It will always go to the table statistics to decide that. So in this dispatcher plan, during that phase, it will go ahead and check like how many records we might see. Let me go ahead and see the statistics, the column statistics. And if, for example, in this picture, right, you see like left side, you see the agents with less than 10,000 listings. Let's say we are searching on the agents which have like number of listings, and it will see the number of records that it gets generated. Like for example, with the agents less than 10,000 listings, then go ahead and use the index seek and the key lookup, and then only allocate certain memory. But if the agents are like producing more than 10,000 records and less than 1 million listings, then just go ahead and use the scan as well as allocate medium memory grant. But if it is more than 1 million listings, then go ahead and use the plan which have a scan and the large memory grant. So basically this dispatcher plan will have all the logic in it, where to go, which plan to execute based upon how much of data is getting produced, like is giving the output based upon that. And it always uses the statistics information on the columns that you are running. So basically most of the times it uses the equality parameters, like for example in the where clause that you mentioned, like where agent id is equal to, like it will go ahead and search on those equality operators and then do this logic. So that's how the parameter sensitive plan optimization works. Now let's go ahead and see the demo on these two features. Like the first one is the query store hints. Christina, are you able to see my demo? Like,
I can, yes. Thank you.
awesome. So we are using the Adventure Works database, and I am going to use the um, Azure SQL database for this. Let me log in. So query store hints are automatically enabled on by default on the, sorry, let me do this first. So basically, query store hints are automatically enabled by default on Azure SQL database. So, and then it is enabled on SQL Server 2022, but then you need to have the enterprise edition if you are using on-prem server. So basically, like if you are not having the query store and if you are not having the query store hints, the normal way of using the query hints is to use it in the option within your query. So basically, this query is just doing the select, but then we want to, for some reason, we want to recompile and then also use the hints. This is just an example of how we use on the basic queries. Like we use the option recompile as well as the use hint. If you are using, like, for example, query optimization, optimizer compatibility level for this particular plan, for this particular query, use 110. That's how you do it with the query hint. But then we would like to go ahead and create a store procedure for this demo. All I'm doing is like I'm just selecting a couple of columns from this table, sales order detail and large table, and we are searching on the product ID with a value, parameter value. Let me go ahead and create this store procedure. And then um, by default, like on query store, or like the query store is enabled by default in Azure SQL database. So it is automatically enabled. You do not have to make, but if you want to turn it off, you can turn it off, but um, it is always enabled. So let's go ahead and refresh. To see, this is the query store feature here. And then it is automatically enabled. So um, let me go ahead and clear out my query store. Like I did not run anything, so you cannot see anything in the query store. So let me run the query store clear. Set query store clear will clear out everything from the query store if we have anything. And then I would like to clear out my procedure cache as well. Again, do not do this in production. It will blow up all, it will remove all the plans from your cache. So procedure cache, we do not want to do that in production, as well as do not clear out query store if you have that. So be careful. So I will execute. We have just created this store procedure, right? We have just created this store procedure. So the first time that you run this store procedure, this plan will be saved inside the cache. So let me go ahead and execute these two executions and then enable the actual execution plan on and execute the query. So if you see the results, right, the first execution gave me like 360,000 records as an output, and the second execution just gave me 385 rows. And if you see the execution plan, for the 360,000 records, it is good that it chosen the optimizer choose it clustered index scan. But what about the second one? Like we have just got like 385 records, and is it really necessary that it have to go ahead and use the clustered index scan? No, it is it is good if it can just go ahead and seek an index and then do the lookups if it needs anything. But why did it choose the clustered index scan is because the first time after we created the store procedure, the first time the store procedure got executed, that's the bad parameter. 360,000 records. But most of my parameters are like basically a couple of hundreds of records. So I do not want this to happen. But if we do not have the query store, recompile is the only option. And if we want to recompile, then we need to touch the code like I described, like I showed here. Like generally we have to touch the code of the query. But without doing that, if you are using the query store, you can actually just get the query ID of that particular store procedure. Now, before doing that, let's go ahead and see what's saved inside the query store. So inside the database, there is a query store folder, and I'm right clicking on top resource consuming queries because we have just executed two of them. And there is this bar graph that is shown. If you hover your mouse over there, you can see the query, but then I would like to see the text only. I don't like this chart kind of thing. So I will go ahead and click on this view top resource consuming queries in a grid format. So once I clicked on that, I can see all the details here. Now, if you see the query ID, we just executed one store procedure, right? So as it is a store procedure, it just had one query ID. And then the object ID, like if you see the object ID, um, that's the object that we are using, and the object name, and what is the query that got executed. Now, if you see here, this is a text of the store procedure, but if you see it's shown in the parameterized format, and we do not know what parameters we used. That's how the query store works. It doesn't save any parameter values. And then if you see execution count is 2, we use two different parameters, but since it is a stored procedure, we just have one query ID. And there is only one plan, so there is one plan count. And if you see the plan ID, the plan ID 1 is the exact plan that got generated for that store procedure, right? So if you see here, the query ID is 1. Now we know the query ID is 1 by looking at this, by looking at the query store. But then if I want to get the query ID for that store procedure using the views, query store views, then I need to execute this view to figure it out. So once I execute, it will show me like that particular query that we just executed, the store procedure query, has the query ID of 1. So now we have the query ID. So all you have to do is like you need to know what query store hint you want to use and what is the query ID. That's all you need. And we have the specially designed query store procedure, which is like SP query store set hints. Give your query ID, which is 1, and we want to use the option recompile because we have parameter sniffing problem here. I do not want to touch the underneath code, but I want to fix the problem. So by using this, by executing this, it will go ahead and save this hint inside the query store so that the next time you run the query, it will always take the query hint into the consideration and use that query hint on the top of your query plan and then take action upon that. Now, once I did that, I can execute this view to see like what hints are active. So on the query ID 1, there is this query hint ID 1, and the option we are using is recompile. That's the hint that is currently active on this query ID 1. Now let me go ahead and execute the same executions one more time and see whether this recompile hint is actually active. Now, if you see, the first one still produced like how many? 360K records, and the second one is 385 rows. But did you see this? It has beautifully go ahead and it has actually recompiled without without you doing any modification to the underneath code. We just use that store procedure, and it has actually used the clustered index scan for this particular plan because like we got 360,000 records. But the second one, it went ahead and recompiled. It has sniffed the parameter recompile, did the index seek and the key lookup, and took the proper amount of resources without wasting any resources on this particular query. Now, how do we know like right now at this point of time, it's working perfect. Now, how about I want to also make sure like I want to change the max stop setting on this particular query and I want to put the max stop setting to certain value. Can that be applied along with the recompile option? Now I can I can actually override by removing this recompile and then just put the max stop value. Now I can do that. And then if I go ahead and look at like what are my current values on that query ID 1, if you observe the query ID is still 1 and like the query hint ID is 2, and it has shown the query hint text is max top 1. But what about the previous one? The previous one was the recompile. Now I do not get any history information here because it simply went ahead and updated the query hint ID as 2. But what if one of my developers has the ability to go ahead and update all of these all of these like changing, they can go ahead and change this, update any of this information. They have the owner permission on the database, and then they can go ahead and change this option, let's say. Now, how do you know? Like once you know they have changed, how do you know what was the previous value? There is no way of figuring that information out by using this view, but then there is a way that you can capture that information by using the extended events. And I have written a blog post on how you can actually create the extended event, especially to capture that information. And it's on my blog post. And and if you can see like underneath the query store blog post, you can find that blog post. But internally within the query store, that information is not stored. So that's a problem, right? But I would like to see if that actually max of one is actually being applied. So I would like to set this hint with the query ID one, and now I would like to update the max of one. We have actually did that. Now I would go ahead and clear out my procedure cache. And then I would like to execute the um, same again to see like whether it has actually applied the maxed of one. So if you see here, it has actually did the, because we have removed the recompile, it has actually used the same clustered index scan, which is not good. And then if you see the properties, it has actually applied this plan max stop set to one. But then you can also use the multiple plan if you want to use both of them. Put the recompile as well as the other hints, like no matter how many hints you want, just append those instead of removing it. Now I would like to use both of them here for the query ID one. And then I would like to clear out my procedure cache and then go ahead and execute this. Execution plan. Now it has actually sniffed and then recompiled. At the same time, it has actually used the max stop set to one for both of them, if you see. So that's one of the wonderful feature with the query store. Hints will actually help you um, fix the performance problems very quickly, especially the parameter sniffing problems very quickly without changing the underneath code. So if you see the hints over here, what are the active hints? Now it actually we updated, right? So we have appended both of them. So now it shows like the query hint ID is 3. We have changed for the third time. So the hint ID is 3 and the query ID is 1, and this is the hint. And again, to see all the hints that are actually um, active, like what all hints you can use within the query store, you can go ahead and look at this Microsoft Docs. So so the query hints is completed, the demo, and we will go to the PSPO, parameter sensitive plan optimization demo right now. But before moving forward, like Christina, does anybody have any questions?
I haven't seen any in the chat, so you can continue unless some pop up, I'll kind of ask you along the way.
Sure, sure. So we are going to see like we are going to use a Stack Overflow database here because it have lot of data for our demo. So I'm using the query store, like I'm enabling this option. Again, we do not require the query store to be enabled for PSPO to work. But since we are using the SQL Server 2022, I have just copied, like this is a 2016 database, but then I have restored and then I'm enabling the query store on the database. So, and then these are all the options, the configuration options that I'm using on the query store. So actually, if you are in the latest compatibility mode, the parameter sensitive plan optimization is turned on. But if you want it to do the T-SQL, then you can do by altering the database scoped configuration, set parameter sensitive plan optimization to be turned on, and then enable that on the database. Oh, so I have to put in the database Stack Overflow database. And right now we need to make sure like it is in the latest compatibility mode 160 is SQL Server 2022. Now, once I enable that, let's see if, yeah, once I enable that, let me go ahead and create this store procedure. If you observe, all it is doing is like selecting from the users table where reputation is equal to reputation parameter and order by display name. So I would like to go ahead and create this simple store procedure on the Stack Overflow database. Right at this point of time, would like to go ahead and see the histogram information on that particular column value reputation. So I would like to see how the statistics histogram look like. So statistics is something like we are going to see the SQL table level statistics on the column reputation. So if I execute that, you see the results like every statistics. So statistics is some like if you do not have much knowledge on the statistics, table statistics, like the column level statistics, let me give you an overview of what the statistic is. So the statistic is like a table level internal table that will be built whenever you whenever you create an index on a column, the statistic will be automatically created, and that statistic is a table. It looks like a table which you are seeing right in front of the screen with maximum 200 rows. Maximum it can have less than that based upon your data. If you see here, we have 194 rows, and it will describe the values, how the flow of your data inside of that column looks like. SQL engine will always use these values to decide and estimate how many number of rows might show up when you run the query searching on that column. So if you see the range high key here, the main thing that you need to focus is the range high key, and we are so this is the histogram on the on this particular column reputation. So in the reputation, we have these many values. So it has randomly chosen the value. Like um, if the reputation value is 1, then we have these many rows with the reputation value 1. With the reputation value 11, we have these many rows. So it will describe the distribution of the data on that particular column. Now I have did order by on the number of rows. So with the number 1 value, with the reputation value 1, we have these many rows. And if you scroll your mouse with the reputation value of like any of these, right? I believe I will take 5714 in my next query, 5714. If you see 5714 with the reputation value of 5714, we just have equal number of E8 rows, just E8 rows. So just imagine like the difference between this as well as E8 rows. So these two are like parameter values. Those are like two different, way too different values for the parameter, right? Those are the two values. So let me go ahead and execute. This is a parameter sensitive problem. Again, the parameter sniffing problem. Now let me go ahead and execute these two, or like these three, even the reputation number 13. If you see here, let's see on the reputation number 13, if we find, uh, I don't know where it is, but then even the reputation number 13 might have like only few number of rows for sure. I'm just seeing 31. Um, maybe it will produce only few records. So let's see. So that's the distribution of the data. Doesn't mean that it will always have the entire number of values, like all the values of the reputation. It will just show the averages, and then it will pick up those some of the values. It will not put the entire column data here because it will definitely be the number of rows we have on the table if we do that. So it will show the distribution of the data. Now let me go ahead and execute these three couple of times. If you see, it's executing couple of times, right? Now, if you see the first execution, index seek and key lookup, because we have like only 8 rows, 8 rows three times. And the next execution, if you see how many, 1 million rows. And for that execution, if you see after third one, it did clustered index scan. Did you see that this value, like it has actually taken the execution plan based upon the values? If you see, even this, the last one also took like in clustered index scan based upon the values it have designed it. Now, if we see the plan cache, how the plan cache looks like. Now, 3 plans are saved here. If you see, like previously, if you are not in the SQL Server 2022, it used to just save 1 plan and then use the same plan no matter what parameter you use. But if you see the results here, how many times we executed each of the execution is given, because we have executed 3 times, 2 times, and 3 times. So it have shown 3, 2, 3, and then these are the plan handle, like 3 different plans. If you see here, the IDs are different, right? Um, and then if you see the text and then the object type. So we have 3 plans that got saved because we have updated in the SQL Server 2022 the latest compatibility. So if we want to see like more information about like variant information, like we have discussed, the variant is nothing but the query plan. Query plan is known as variant. And then we have seen the dispatcher plan, right? The plan that have all the logic in it. Now let's see if we can find that by using this um, query. I have couple of queries here put together. Um, so which will have like, these are the execution count information, right? And then this is a different plan. This is just the query that I have just executed. So if you see the query hash is the same for all the executions because that is a stored procedure. It have the same query hash. But if you see the query plan hash, they have 3 different values because it have executed. Like if you see the query plan hash, it should, I think these both are the same. These both looks like the same because the dispatcher plan thought like these two execution can use the same plan. So these 3 executions have the different plan hashes, 2 different like different plan hashes and the different plan handles on them. And if you see here, like you can also see the plans, like query plans from here. They have the different query plans. Let me close this one and then go to the other queries. So these are like, again, we are querying here by using the query stats information and the query text information. We are not executing the query store information yet, but I'm trying to run all these queries to see like what all information can we get from these queries, right? Again, the query hash can be the same because it's the same stored procedure, but they might have the different plan hashes. So right now we'll clear out the procedure cache and then the um, query store. But before doing that, let me just execute these two. So I have taken these 2 queries from Microsoft Docs. So the top, this query will only give the variant information, meaning the query plans information. But to look at both of the variant as well as the dispatcher plan in a single view, you have to execute this query. So results in, if you see here, it will give the plan type. The query plan, the query variant plan is the actual plan, and the plan ID. If you see, we did not execute it these many times, but we executed these many times, and that was the reason why it have shown all of this, call all of these values. But if you see, like, plan ID remains the same. These many times we executed, but it still have the plan ID 2, plan ID 3, and plan ID 4. And if you see, like, we have so many dispatcher plans. Like if you see the dispatcher plan for this is the same exact query. If you see, it has the same query hash. If you see that it's a same store procedure. So if you see the dispatcher plan, how does it looks like? It will show like the multiple plan. This is a plan. This is the dispatcher plan where it have all the logic in it. Like it will decide which based upon how many records it produce, it will go ahead and decide which execution plan it uses. That's how it will go ahead and save all the plans. It always have one query hash, but it can have the multiple what is this? Multiple um, dispatcher, like the variant, right? Let me go ahead. This is the PSPO optimization, parameter sensitive plan optimization demo. Now let me go ahead and share back my slides. And then let's talk about like memory grant feedback, persistent and percentile. So before understanding like how the memory grant feedback works, let's see where does these memory grant feedbacks come from, and how SQL engine actually um, use these memory grants. How does it allocates the memory grants to any of your queries? So for that thing, to understand that thing, we need to understand how the query actually executes on the SQL Server. The diagram that we have seen previously was for the query that is actually using the query store, and that has actually a forced plan. But uh, this slide will actually show you how a regular query works behind the scenes. So any query that executes on the SQL engine, it will first go through the transformation phase. Basically, it will go ahead and look into the statistics information, and then the table level statistics, and then build multiple execution plans for the query. So for each of that execution plan, the multiple execution plans will be generated, right? Upon that, each of these multiple execution plan, like each of that execution plan that got generated, it will go ahead and check for the cardinality estimates. Cardinality estimates are nothing but, sorry, cardinality estimates are nothing but the table level estimates. These estimates always come from the table level statistics, column level statistics. And once all of these, each of these execution plans get these cardinality estimates, the lowest resource cost ones will be saved inside the plan cache. So once the query, once the plan is getting saved inside the plan cache, it will go ahead and use that plan cache again to go ahead and execute the query. But even before the execution, the memory grants will be allocated to that particular plan based upon those cardinality estimates. Again, those statistics, right? And then the query will go to the execution phase. Now, what if this one thing will go wrong? What if the statistics are stale and they are not updated properly? That will actually affect the cost, because based upon the estimates only, the cost will be decided. And if the cost is not properly decided, then the wrong plan might be saved inside the plan cache. And based upon those wrong estimates, the wrong memory grant will be allocated, and everything the execution will be affected. Because if, for example, if there is a query, let's say the store procedure that you are executing, and it should actually produce 1 million records, but your statistics are stale. Your table level, column level statistics are stale, and that statistics on that particular column is only telling that for this particular parameter that you passed, you will only get like 1,000 records. But when you actually executed the query, you are getting 1 million records. For some reason, the statistics are not updated. That's an OLTP system. Data gets inserted a lot, but then autostats are not up. Autostats is not turned on, and you did not updated the statistics. What will happen in that case is SQL engine will always decide upon those statistics. So the statistics are telling me 1,000. Who cares about how many records are getting executed? I only go with the estimates. So it's saying only 1,000. So I will only allocate the memory grant for the 1,000 records, because I don't want to waste my memory, right? I don't want to waste my resources over here. There are other queries are running at the same time. So it will only allocate only certain amount of memory to get that 1,000 records. But then in fact, when the query goes to the execution phase, it is giving 1 million records. Now, how do you think it will go ahead and get those resources from? There is no way that it can do that. So all it will go ahead and do it will suffocate, and then it will go ahead and request the SQL Server to grant more memory. But the memory is already granted even before the execution, right? That is a process. So what it will do is it have to go ahead and process all of those. It have to go ahead and um, do the scan, because we are going to get that 1 million records right now. It have to go ahead and scan the clustered index. It need more memory. So it can't get the memory, and then it will go ahead and use certain operators, like it will go ahead and spill to disk. The spills will happen. It will go ahead and use the tempdb. It don't have any way to go, so that it will go ahead and use the tempdb and put the records in tempdb, and then go ahead and search from there. It will go ahead and spill to the disk, and that's when the performance issues happen in those kind of scenarios. So all this is happening because of this one thing that is outdated, which is the cardinality estimates. The statistics are out of date. Now, why I am even talking about all of this, right? Because to understand memory grant feedback, that's how much important memory grant is. Even before the query gets executed, the memory grant is allocated for the queries. Now, how do we like until now, it is up to us to go ahead and always look for those statistics, whether they are updated, whether your queries are using the um, uh, uh, proper cardinality estimates. Because in SQL Server 2019, in SQL Server, I believe it's 2017, they have changed the cardinality estimates. The way the cardinality is changed. So sometimes your queries needs to run in the old cardinality um, estimates, with the old cardinality estimates, and the new one. It is up to you to go ahead and look into all of this, and like go ahead and look into the execution plan to see if there are any spills. But in SQL Server 2022, by using the query store data, it will go ahead and access all of your execution, your workload. Basically, it will go ahead and look at all of that workload saved inside your query store, and it will basically save that feedback, which will be persisted, by the way, even upon the restart of SQL Server. And it will go ahead and grab that feedback, and it will make the necessary changes based upon the feedback on your query. Like if your query is getting a low amount of memory grants, then this particular feedback will kick off, and it will increase the feedback automatically for you, so that the query doesn't have to spill to disk anymore. So it will have to adjust. I will not say that only the query have to run one time or two times to make these settings. it have to grab the feedback upon your workload. So though that query have to run certain amount of time and to grab that information, right, into your query store. So the basic goal of this particular memory grant feedback is to avoid the spills and to increase the concurrent workloads that are happening along the way at the same times, the other workloads that are happening along the way without spilling to the disk, properly assigning the memory grants that is actually needed without giving less amount of memory grant than required. It will always make sure that the memory grant that is being allocated is above the grant that is required. Not too much, not little, but always above the grant that is actually required. So in SQL Server 2017, the memory grant feedback was active on the batch mode, but for the SQL Server 2019, they have also included this feedback on the row mode as well. So the improvements are basically because we are using the query store, all the feedback that is being saved will be persisted even after the restart. Now, before using the query store, like this information, all this feedback information is lost, the memory grant feedback information lost after the restart. So this will actually solve the problem. It will persist the data. And for example, if you are wanted to do the failover, if you are having the availability group, if you want to do the failover, even if you do the failover, the data will be still persisted, and it will adjust the memory information. Like it will always save that adjust memory information inside the query store. So it will grab that information even after the restart. So how does the memory grant feedback worked before 2022? It used to only see the last execution, only one single last execution. If the last execution took 20 MB, let's say, of the memory, then the next execution used to take the same 20 MB because it used to only depend upon the last single execution. But what if the next execution requires the 800 MB of memory, right? If you see the diagram here, the first execution required 800, and then that information is actually saved. But the next execution only required 5 MB. But then, because it saved the last execution is 8 MB, it used to use that 800 MB only when it required 5 MB. So that's not ideal here because the feedback go back and forth, back and forth. It can't make it even out because it is only depending upon the last single execution. So that has actually caused the problem, and because of so many fluctuations, the memory grant feedback will be turned off on that particular query. But in SQL Server 2022, it because it saved the data, the feedback inside the query store, now it can go ahead and observe the entire workload, and then based upon the entire workload, it can even out the feedback. It can actually look at the history of the execution and then avoid the spilling to the disk with the good memory grants because now it has that feedback. And then if you see this diagram over here, right, the blue one especially, that's how that's how it will go ahead and look at the feedback and even out the memory over time. Now, even here, if the fluctuations are too much, then it can go ahead and like it will turn off. But that percentile is very, very small because at this point of time, it is based upon the entire workload feedback. So it will always make sure the percentile feedback um is like even out. It is always even out, even after the restart. It will go ahead and grab that information from the query store. So basically, it will first go ahead and like, for example, if you are running a query, right, it will go ahead and check if that query is actually eligible for the memory grant feedback. If it is eligible, it will go ahead and start collecting the data. It will validate the data, And then it will go ahead and look at the workload, and it will start allocating the memory grant over time until it is stabilized. So by looking at your extended event information, you can grab this particular information of like whether your memory grant feedback is stabilized on that particular query or not. Now, cardinality estimate feedback is where like again, this is cardinality estimates we talked about in our previous slide, where I described how the SQL engine will work behind the scene. It will always depend upon the statistics, right? Now, it will always depend upon how many rows are estimated to get out of the query. It is always depending upon the estimates, not the actuals, estimates. Um, and that is always depend upon the distribution of your data within your column statistics, like how your column is actually distributed the data. Um, and then based upon that distribution, your memory, CPU, what kind of joins it can use, what kind of indexes it can use inside your plan will be decided based upon these estimates. So, there is this one model, related assumptions will be used based upon the query store history. Again, the history of your executions. It will use the cardinality estimates techniques, which are already there. So these techniques are like, for example, predicate independence versus correlation. So what is this predicate independence versus correlation? This particular technique will always make sure it is searched on the equality predicators. Like for example, you're searching on two different columns, right? Where in the where clause, where city is equal to city is equal to Frankfurt and the state is equal to Kentucky, or like city is equal to Frankfurt and the pin code is this one. So both, if there is a relationship between both of those columns, of course, like city and the zip code, city and the state have the dependency, right, in between those columns. So there is a dependency. So whenever there is that kind of dependency on your equality columns, it will go ahead and use the independence, predicate independence instead of the correlation. Because if they are correlated, then that will affect the cardinality estimate. So because it will affect, it will always go ahead and use the default value of predicate independence. So that will look at those two columns as independent, and then the cardinality estimates um, uh, are gathered better. That's how the technique works behind the scenes. So that's one of the correlation. And there are also the other kind of correlation, like containment meaning it will always use like a join correlation, like how many joins are we doing on this particular query, how many joins, table joins are we using, like do we have any relation, like the containment is related to those joins. So it will use that technique, and it will also use the row goal, like um the like how many rows it can get. So those are the three techniques. I'm not going too much detail into these three techniques, but it will use these three techniques to do the cardinality estimation feedback. Again, that data is being captured inside the query store. So it will identify whether the query is actually eligible to do this feedback first, and then if there is like 10x 10x difference between the estimation as well as the actual number of rows that are getting, or like 100x, like if the difference between the estimates and the actuals are way too different, it will go ahead and replace, and then it will make sure those estimates are updated, like, and make sure those estimates are persistent. And in some cases, it will go ahead and use the query hinting method as well. It will automatically go ahead and you update the query hints to use that cardinality estimate. and use that hint. Whenever you run that query, it will automatically use that hint. Check that hint on your query plan, and then use that cardinality estimate hint that it has actually put automatically, and use that. That's how the cardinality estimate feedback works. And all you have to do is make sure that you have updated the compatibility level to 160, and then it will always do the feedback on the repeating queries and with the persisted plans. So to make that happen, the plans should not change too much, and the query should be repeated all the time. So these are the ones that the cardinality estimate feedback is focused on. And it is verified only feedback is implemented. Like, it will first verify, then only the feedback will be implemented. And it will always use the query store hints. Like, if a cardinality estimate feedback is implemented, it will show up in the query store hints as well. The other one is a degree of parallelism feedback. So the main goal of this degree of parallelism feedback is like, it will make sure it will not use the um, it will not use the course unnecessarily uh, when there is no need of parallelism, or if it is using too many cores to run your query. It will go ahead and automatically decrease based upon your workload. It will always decrease that value, DOP feedback value, but it will never ever increase that value. It will always decrease, and it will only decrease until the DOP value of 2, and it can't go below that. So it will it will get that these feedback based upon like the amount of CPU, amount of like elapsed times, and based upon the weights. It will grab that DOP feedback value, and again it will use the query store data. And then you can see these feedbacks in query store plan feedbacks. This is a view where you can see if there are any feedbacks. It will automatically pop this particular view inside the query store. You can see like any queries, whether they are taking the advantage of feedback, and whether that feedback is persisted or not, or whether it is actually validating. If it is in the validation phase, it will also show you that. And um, so after it evaluate, right, it will go ahead and change those max stop values, and again it will never go below 2, and then it will never increase the DOP value. It will always make sure to decrease wherever it is overusing it. It will always decrease and make sure it is even out. And even these values are even they are persisted inside the query store. So no matter if you restart the SQL Server, doesn't matter. It always take those values from the query store and then implement it. So you can grab this DOP feedback value even from the extended events. It will clearly show upon like every query whether the DOP feedback is currently being validated, um, if it is in the evaluation phase, validation phase, or if it is a stabilized one. And yeah, I think I covered all of the intelligent query processing features which are in SQL Server 2022. Again, I have to do demos on each of these feedbacks, but again, like I'm still working on those. They are going to come up in my near presentations. But if you would like to know more about these features, like along with the demos and stuff, like please visit these two links over here. The first one is like from the data exposed. It have an entire 1.5 session which give you the entire information on like how these features actually work. And then the bottom reference is from the Microsoft Docs. If you are like a reading person, if you are a reading person, you can get a lot of information from that link as well. And I would like to thank you all the audience, and thank you Christina for giving me this opportunity to present for your user group. I'm really honored to be a part of today's presentation. Thank you.
Thank you so much. You're always just such a role model for speaking. So we really appreciate you taking the time to spend your evening with us and talk about these things. Thank you.
Yeah, yeah, sure. So if you wanted to contact me again, I have my contact details here. Um, you can quickly, see my contact details. You can contact me on LinkedIn, as well. So yeah, if you have any
Yeah,
questions, please feel free.
definitely follow Deepthi on LinkedIn because she posts a lot of great stuff there.
Thank you, Christina.
I love it. So, and I really liked your diagram at the beginning of the query store because
Oh, this one, right? Yeah,
yeah, because I'm not really an audible learner, so I can listen to things, but I need something visual with the talking. So having those
right.
diagrams is really helpful for people like me. And I really liked that.
Yeah, I like this took a lot of time for me to prepare
Yeah,
because I was like, I did this from scratch. So
yeah, yeah. No, I like it. Like
yeah, thank you.
if I can like go through each thing, stop and think about it, and
Right.
kind of go through the okay, I got it. So go to the next
Yeah.
step and stuff like that, and things that I can totally understand fast, I can just whiz through. So it's really helpful.
Right, right. Thank you.
Yeah. So do you have this the queries from your demo available for users? And I'm asking purely for selfish reasons because I
Yeah.
like to play around with it.
Mhm. Sure. Can like I will upload this to the
Sure.
GitHub because this is fairly new. Like I said, I did not yet upload it. So at this
Absolutely.
moment, like immediately after this session, I can upload it and I can share that link um on the meetup group if that is okay.
Absolutely. Yeah. Would love it.
Yeah, I'll do that.
Okay. And so that's it. Do you have any final words?
Um, yeah, I mean, keep learning, and then um, just an advice of like if you see like what is going on in technology, like cloud, especially every single day you see some or the other thing popping up, and like if you are a DB or a developer or any technology professionals, definitely while sleeping, before sleeping, you get those like thoughts like, oh my God, where am I going? What am I doing? Like, will I have my job? Because these are the these are many things like think about it, Christina. We are like we are the people like who speak about in the conferences, and like we need to be like we are forced to learn new things. But think about like
Constantly.
busy
Yeah.
professionals who are working 8 hours a day, and then just think about like how much of a pressure they have. Like they
Yeah.
think like we know everything, and we think like people they know everything because like we have to focus on certain topics. We only learn those topics, and like, oh my God, what's going on LinkedIn? Like they post a lot of things. We
Yeah.
keep on learning, but then my sincere suggestion, I have learned it in the hard way, that do not get stressed out, because every single person, even the Microsoft
100%.
professional, like even the people working for Microsoft are having the same kind of thoughts like us. Like they are only focused on certain technology and not all of it. Like
Yep.
if you're wanted to learn on one technology, just just focus on that one. Forget about all the technologies that are getting popped up everywhere, because we are not an encyclopedia. We just learn
Yeah.
things one by one. We are not like multitaskers where we learn everything at the same time. So do not take that pressure. My sincere suggestion, because I have the thought sometimes I can't even sleep.
Yeah.
If I go
Yeah.
to
Same
social
here.
media and see on like Twitter, I feel like, oh my God, what's going on? Every single day they release new stuff, and how do I catch? How do
Yeah.
I catch with this?
Yep.
But but you know,
My number
we
one
are
thing I look
all.
for when I interview people,
Mhm.
especially junior people, but really anybody, is what is their capability and desire to learn new things? Because in this
Exactly.
industry, you just absolutely it's a requirement.
Yes. And
You
then
have that
start from
innate
basics, and
curiosity, really,
then
is what I look for.
Exactly. And then we can always learn, right? One topic at a time.
Yeah.
If you wanted to focus on one thing at a time, just focus on that one
Yeah.
thing and do not jump into the different things, because that will only confuse us, and we will not be good on any of that, right? So
Yeah.
focus on one thing at a time. And I know I'm in the same boat, so
It's hard for me. I'm always like pinging all over the place. Oh, I want to learn that. Oh,
me
squirrel,
too.
squirrel.
Me too. And not be good at any of any of that. Like
Yeah, that's okay. You can have I think it's really good. There's that book Range, and it talks about having that wide breadth is actually an excellent thing. And you can have deepness in certain areas of it, but having that width, because you can abstractly apply it to other things, is just so super important nowadays.
absolutely. Absolutely. I would love all of you to get connected with me on LinkedIn. It would be an honor. Again, you can know like any more, because I'm also talking about the other sessions as well. I'm like literally preparing them, so you can know like where I'm speaking, when I'm speaking. So yeah.
Deepthi has a ton of great sessions, so make sure that you look them up. Thank you. And with
Thank you,
that,
Christina.
we will conclude today's meeting. Thanks everybody for joining. And sorry about the link earlier. I guess I did something wrong and it didn't upload, and I thought it had, but apologies.
Yeah, no problem at all. Yeah, we are good. We are good. Okay, bye everyone. Good
Talk to you
night.
later. Bye-bye.
Talk to you later. Bye.